Hello everyone, today we'll learn how to implement a low pressure line pressure regulator in G Suite and understand how it maintains fuel pressure at around 10 bar. By the end of this tutorial, you will understand how a low pressure regulator works, how to model it in GTPower, how to set the spring and valve parameters, and how to verify pressure stability in the simulation result. Okay, so this item is low pressure line pressure control regulator. A pressure control regulator is a device designed to maintain or control the pressure of a system at the specified value. It operates automatically and in a regulated manner to keep the desired pressure constant and prevent undesirable pressure increases. This figure shows the pressure control regulator system. As illustrated, the regulator consists of an inlet valve, valve spring, a valve mass and a spring, and damper. Port 1 is connected to the outlet line of the low pressure pump, while port 2 is connected to the fuel bypass line returning to the tank. As you can see here, this is port 2 and this is port 1. The function of this system is to maintain the fuel pressure at the outlet of the low pressure pump at approximately 10 bar. So let's go to show help. Okay, the subject is used to model a ball puppet with a conical seat for hydraulic or pneumatic applications. And what we have here, the main tab. We have main tab options. Let's go. What are these items? At main tab, we have pressure, force, direction. Direction of force, positive or negative. Positive, the force due to the seat side pressure is in the positive direction. This also means that a positive mass displacement will result in an increase of the seat side volume and a decrease of the volume opposite the seat. And negative, the force due to the seat side pressure is in the negative direction, okay? And seat diameter is diameter of the seat. We have seat half angle, ball diameter, rod diameter, and maximum discharge coefficient. What is this? The maximum value of the discharge coefficient. Discharge coefficient is calculated as a function of flow number using a hyperbolic tangent function as shown below. Critical flow number, lift at zero position and pressure force model. Number of nodes, squeeze damping with fluid inertia effects. And the same way, we have options tab, jet force multiplier, jet angle, its conduction flange and user model object. So you can see this figure, the schematic of the puppet illustrating the various attributes. And you can see parameters that I mentioned above. For example, D, theta, alpha, okay? Okay, so the other parts, we have mass and a spring. So let's go, what is this? At first, again, we have main tab, mass, initial position, initial velocity. The mass object describes attributes of mass parts used to represent a generic lumped mass, which is acted upon by external forces in one dimension. And about mass, main tab, we have mass, initial position, and initial velocity. In the same way, we have a spring that has piston diameter, rod diameter, stiffness. Okay, let's go to help. This object is used to model interaction between flow and mechanical systems. We had pressure, force, direction, position, positive or negative, piston diameter or diameter, nonlinear spring, for example, initial position, pressure, force, multiple layer, volume change, multiple layer that you can fill them in. And how pressure force calculated? By this equation, the force transferred to the mass is due to the pressure and the spring force, where P is equal pressure in the attached flow volume, piston diameter and rod diameter, and external forces from any components attached to the mechanical part, mass position, spring stiffness, and preload force. And the other equation for volume change calculation. And this is a figure of example. Here we have flapper valve, mass, and piston and spring. Okay. Now you know how to model a regulator in GT Power.